Hi, welcome to our group project.
Hi guys, my name is Halimatul Saadia binti Hashim and my metric number is A202276.
Hi, my name is Faizana binti Rozain and my matrix number is A204326.
Hi, my name is Nur Alisa binti Anwar, A202641.
My name is Nurhana Batrisha binti Abdul Mu'ain, A202265.
Hello, I'm Mazatul Shima binti Marzuki, matrix number A202871.
Hi, my name is Nuri Fadilah binti Safi'i. My matrix number is A202868.
Today our group will be presenting about X-ray in food irradiation. First of all, I will explain about X-ray first. So, X-ray is a packet of electromagnetic energy, which is photon that originally from the electron cloud of an atom. This is generally caused by energy that is changed in an electron, which the electron will move from a higher energy level to a lower energy level and causing the excess energy to be released. So we can simply put that X-rays are similar to gamma rays. However, the main difference is the way they are produced. X-rays are produced by electrons external to the nucleus. Usually, X-ray has smaller wavelengths and higher energy than ultraviolet waves. In addition, X-ray photons are highly energetic and have enough energy to break up molecules and hence damaging the living cells.
Are you aware that X-rays are used in food irradiation? Food irradiation has been approved by many health organizations, including the World Health Organization, as a safe and effective method for reducing the risk of foodborne illnesses. It's important to note that the use of ionizing radiation in food is regulated to ensure that the treated food remains safe for consumption and the radiation levels are within acceptable limits. The process does not make the food radioactive, and irradiated food is generally considered safe to eat. However, X-rays are not typically used in food irradiation.
Okay, now I'm going to explain about mechanism of irradiation foods using X-rays. Firstly, food such as fresh meat and spices will leave processing facilities, which is factory, and arrive at irradiation facility. Next, at the irradiation facility, foods ride on a conveyor belt through an irradiation chamber as shown in the picture.
In the chamber, foods pass under a beam of radiation. This kills germs by breaking the bones that hold the germ's DNA together. So what happened during this process? So firstly, X-rays will kick out electrons from atoms in the food, creating charged particles and free radicals. Then, the ions and free radicals will interact with the DNA and other cellular components of microorganisms. This interaction damages their genetic material and disrupts cellular functions. The damage caused by X-rays makes it difficult for microorganisms to survive or reproduce, effectively eliminating or reducing their presence in the food.
Once the food leaves the irradiation chamber, most of the germs or bacteria are destroyed. Then, the irradiated food is sent to grocery stores and food service facilities. And lastly, customers can identify which one is irradiated products by looking for the radura symbol, the green symbol. It will be on the food label or the product signed with one of these statements, which is treated with radiation or treated by irradiation.
So, the next one is advantages of X-ray in food irradiation. The first one is pest control. X-ray irradiation is effective in controlling insect pests and parasites in stored grains, fruits, and other food products. The treatment disrupts the reproductive cycles of insects and prevents them from infesting and damaging the food. The next one is enhanced food safety. This happens by eliminating harmful bacteria, parasites, and other pathogens that present in food. The ionizing radiation damages the DNA of microorganisms, preventing their reproduction and ensuring the safety of the food. Next, extension of shelf life. X-rays can extend the shelf life of foods by destroying inactive organisms that cause spoilage and decomposition. Furthermore, X-rays can reduce spoilage and waste by controlling the microbial growth. X-ray irradiation can reduce spoilage and waste in the food supply chain, contributing to more sustainable food practices. The last one is preservation of nutritional quality. X-ray irradiation can help preserve the nutritional quality by minimizing nutrient loss compared to traditional heat-based methods of preservation. That's all for advantages of X-ray in food irradiation.
Disadvantages of X-rays in food irradiation. First, destroy vitamins content. Food irradiation causes food to lose about 2% to 95% of vitamins. For example, eggs lose about 80%, green beans 95%, broccoli 50%, orange juice 40%, and beef lose double the amounts of trans fat. Second, it can only be used on a very limited range of foods. Some foods, such as dairy products and eggs, cannot be irradiated because it causes changes in flavor or texture. Third, it is still a relatively expensive technology. This is due to additional handling, packaging required for irradiated products, cost of irradiation process, and post-irradiation sampling for pathogen testing. Fourth, it is ineffective against viruses. Irradiation does not destroy all pathogens. Microorganisms such as bacteria, viruses, fungi, or parasites that are infectious and cause disease. And lastly, unique radiolytic product. Radiations can do strange things to food by creating substances called unique radiolytic products. These irradiation byproducts include a variety of mutagens, which is substances that can cause gene mutations, polyploidy, and abnormal conditions in which cells contain more than 2 sets of chromosome aberration, often associated with cancerous cells, and dominant lethal mutations, a change in a cell that prevent it from reproducing in human cells. Making matters worse, many mutagens are also carcinogens.
Applications of X-rays in food irradiation. As we all know, X-ray is commonly and widely used in various fields. So, during food processing, packaging and manufacturing, businesses use X-ray inspection systems to maintain strict quality control standards. These machines will scan the internal structure of food products to check for foreign objects or other non-food items such as plastic and metal. Next, X-ray are also able to detect missing products in packings, unwanted air bubbles, overweight or underweight some products, the broken products, shape deviations, and even incorrect positions of individual components can be detected to some extent. This not only guarantees the product purity but also further improve the quality of the end product. Lastly, X-rays are also effective in detecting bones in meat products, such as burger patty. This will ensure that bone fragments are removed during processing and reducing the risk of injury to consumers. There are 3 types of dose application of X-rays in food irradiation. The first one is low dose application, which is 0.3 kilograms. The example is herbs and spices. Low dose X-ray irradiation is applied to dry herbs and spices to ensure they are free from harmful microorganisms and to extend their shelf life. The second one is medium dose application, which is between 1 to 3 kilograms. The example is poultry and meat products. Medium dose X-ray irradiation can be used to treat certain poultry and meat products, reducing the risk of harmful bacteria like Salmonella and E. coli. And lastly, the high dose application, which is more than 35 kilograms. High dose X-ray irradiation can be used for certain ready-to-eat meals to achieve both extended shelf life and enhancing safety.
Thank you for watching. Bye!